See, today I'll be starting with the some basic principles of organic chemistry. Some basic principles of organic chemistry. Some basic principle of organic chemistry. Some basic principles of organic. It is a PU1 chapter. After this chapter, I will move to the PU2 chapters. Okay. First, I am trying to complete the PU2 chapter because you see the weightage. So that are mostly from the PU2 one. And after that, I will be starting with the PU1 chapters. Okay. So this is the basic part. So I need to start with this one. So the basic principles of organic chemistry. Some basic principle of organic chemistry. Got it? Write down some basic principle of organic chemistry. Now, first one is your classification of the organic compound. Okay, classification of the organic compound. Classification of of organic compound. Classification of the organic compound. See here. So you know that organic compounds can be classified into two parts. First one is your open chain, and the second one is your closed chain compound, right? One is your open chain compound, one is your open chain compound, and second one is your closed chain compound, right? Open chain and then closed chain compound. Got it? Open chain, then the closed chain one. You know the open chain compound, right? Open chain means you have the no ring, right? For example, you have the compound like this one. This is basically your open chain compound. Now coming to the closed chain compound. Closed chain compound means like this compounds. See here, that is the ring one, that will come under the category of the closed chain compound. Now see here, second one is your closed chain compound homocyclic and the heterocyclic we are talking about. The homocyclic and you have the heterocyclic one. Homocyclic and you have the heterocyclic one, right? Homo means the same one, right? Hetero means basically different one is there. So if in the ring only carbon atoms are there, that will in the category of the homocyclic compound. Cyclic means ring. Homo means same will be there. So if the ring containing only the carbon atoms, that will be in the category of the homocyclic one. Hetero means different one, right? Hetero means different one. Suppose the ring contain carbon and the oxygen. Suppose the ring contain carbon and the nitrogen, that will fall under the category of the heterocyclic compound. So see here, for example, if I'm drawing the cyclohexane will be there. You see in the ring you will have the carbon atoms are there. So this is the example of the homocyclic compound. On the other hand, if you see this example, oxygen, oxygen, you have the oxygen and the oxygen. So in the ring you will have the oxygen as well as the carbon atom. So it is falls under the category of the heterocyclic compound will be there. Got it? Now see here, this homocyclic compound can be further classified. This homocyclic compound can be further classified to the alicyclic and the aromatic compound and the aromatic compound. Got it? Understood? However, the heterocyclic compound can be also classified into the aromatic, alicyclic and the aromatic compound. Alicyclic and the aromatic compound. Alicyclic and the aromatic compound and the aromatic compound. There is nothing much to discuss here one, because you already know the alkanes and the alkynes will be there. Got it? So you have the hydrocarbons mostly, and some of the compounds may contain the different functional groups. So see here, you can have two parts. One is your hydrocarbons one, right? One is your hydrocarbon one. Means hydro means the hydrogen, carbon means the carbon. So compound containing only the carbon and the hydrogen will fall on the category of the kya hydrocarbon. So it is like a open chain hydrocarbon, isn't it? Open chain hydrocarbon means, for example, you can write like kya this one, isn't it? This one is example of a kya open chain hydrocarbon. Second example, hydrocarbons containing the kya functional group, hydrocarbons containing the functional groups. Got it? Functional. For example, you have the kya this double bond O and U. You see here, this is the hydrocarbon, but it is also containing the kya keto group. So it is a hydrocarbons containing the kya functional group. So compounds containing, better you can write compounds containing functional groups will be there. Now see here, you have the alicyclic and the kya aromatic. So it will further classified into alicyclic and the aromatic one. So see here, what is alicyclic and the aromatic? Aromatic, you know, right? Aromatic means that the compounds which have how much 4n plus kya 2 pi electrons, right? 4n plus 2 pi electron. Second, this is the kya cyclic one. Third one is your kya conjugated one, right? Third one is your basically kya conjugated one. So these are basically kya aromatic compound. For example, you have the kya benzene is there, right? You have the kya benzene one. So this is basically your aromatic compound. If you look at this one, you will see the ring is there, that is a cyclic. Got it? You have the conjugation, means basically the pi clouds are basically kya in the resonance, and the first one is your kya 4n plus 2 pi electron, that is how much 6 pi electrons are there, that is kya 4 into 1 plus 2, which is equals to kya 6 pi electrons. So this compound is basically your kya aromatic one. Got it? Similarly, you have the kya this example, you see, suppose you have this one furan is there. So this is basically your kya furan. So this is also a kya aromatic compound, but this is the aromatic heterocyclic compound. This is the kya aromatic homocyclic compound. Got it? Because this is kya also having the kya 6 pi electrons center. Got it? Similarly, you have this example. See here, suppose you have one, two, three, four, five, six, seven, two, three. See here, suppose you have the positive charge here, like this compound. See here. So this compound is basically cyclic and it's containing the kya planar also. This is basically planar and planar also. And you will have the kya 6 pi electrons are there. So this compound is also or kya aromatic compound. This is kya also compound is kya aromatic one. Got it? Understood these things? Now the next topic, see here, nomenclature of the kya organic compounds. Got it? And also the types of carbon atoms, right? You know the meaning of the primary carbon, secondary carbon and the tertiary carbon. So see here, what does this mean? Second topic is your types of carbon, right? Types of kya carbon and the kya hydrogen is the types of carbon and the hydrogen. What does this mean here? See here, if it is a 1 degree carbon, it means it is attached with kya one carbon only. Got it? It is attached with with one carbon only. If it is a 2 degree carbon, that means it is attached with kya 2 carbon. If it is a 3 degree carbon, then it is kya 3 carbon, and you have the 4 degree, that is the quaternary one, that is means how much 4 carbon. For example, see here, if I am asking you this example, see, okay, so how many 1 degree carbon and how many 2 degree carbon or how many 3 degree carbons are there? तो देखो यहाँ पर, if you look at this example, you will see that this carbon is connected with kya 3 carbons, right? This carbon is basically connected with the 3 carbon. So I can write here it is kya 3 degree carbon, isn't it? Got it? So this one, this is the 3-degree carbon. This is also our kya? 3-degree carbon, because it is attached with the 3 carbons are there. So you will have the 3-degree carbon. Again you will have the kya? 3-degree carbon is there. So basically 3 3-degree carbons are there. Now looking for the kya? 2-degree carbon. Do you think there is any 2-degree carbon here? No, because 1 degree, 1 degree, 1 degree, 1 degree, and 1 degree is there. So the rest are basically or kya? Rest are basically, this is 1 degree carbon, this is 1 degree carbon, this is 1 degree carbon, this is 1 degree, and this is basically or kya? 1 degree carbon is there. So you have to look whether it is attached with the 1 carbon, whether it is attached with the 2 carbon, whether it is attached with 3 or the kya? 4 one. Now coming to the kya? Hydrogen one is there. What about the hydrogen? So 1 degree hydrogen means, 1 degree hydrogen means connected with, it is connected with the kya? 1 degree carbon, 1 degree carbon, and so on and so on. That means 2 degree will be connected with the 2 degree carbon, 3 degree hydrogen will connected with the 3 degree carbon, 3 degree hydrogen will connected with the 3 degree carbon, and 4 degree hydrogen is not possible. 4 degree hydrogen, 4 degree hydrogen is basically cannot possible. So see here, this is 1 degree carbon, right? So you will have here the kya? 1 degree hydrogen as well, because this this diagram will look like this one, like hydrogen, hydrogen, and you have the kya? So these are basically kya? 1 degree hydrogen is there. Now see here, this will also have the hydrogen one. So this will basically or kya? 3 degree hydrogen. This is kya? 3 degree hydrogen. This one is kya? 1 degree hydrogen. Similarly, here 1 degree hydrogen, 1 degree hydrogen, 1 degree hydrogen, and here we'll have the kya? 3 degree, and the kya? 3 degree hydrogen. These are the examples of the uh, primary carbon, secondary carbon, tertiary carbon, and the kya? Quaternary carbon. That is 1 degree, 2 degree, 3rd degree. This is known as the primary one. Primary one. This is known as the secondary one. This is known as the tertiary one, and last one is known as the kya? Quaternary one. Got it? Any problem? Now the next part is your kya? IUPAC nomenclature. Now the next part is your basically your kya? IUPAC, IUPAC nomenclature. IUPAC nomenclature I am talking about. IUPAC nomenclature. So see here, what do you mean by the kya? IUPAC nomenclature one. So it is a some systems of rules are there in order to know the kya? Name of that compound. We have the common names also. The common names are not scientific. Common names is like that. It can vary with the place. It can vary with the country. That is why it is a kya? Common name. However, IUPAC name is kya? Internationally kya? Accepted one. Got it? So see here. So how to write the IUPAC nomenclature? The first thing you have to write out the kya? Prefix is there, then you have the word root, and then you will have the kya? Suffix will be there. Got it? So prefix, word root, and then you will have the kya? Suffix. This prefix first will be have the kya? 1 degree prefix, 1 degree prefix, 1 degree prefix, and you will have the kya? 2 degree prefix, 2 degree prefix. Similarly, you have to write 1 degree suffix, you have to write the 1 degree suffix, and second you have to write the kya? 2 degree suffix. So the word will look like 1 degree plus word root plus kya? 1 degree suffix plus kya? 2 degree suffix will be there. Got it? What do you mean by the prefix? When you see prefix means kya? By, try, got it? Sometimes you also write the cycloalkene. So these are all the kya? Prefix one. Sometimes you also end with the kya? It is, for example, end with the alcohol one. All, al. So these are the kya? Suffix one. For example, see here, if I ask you to write the IUPAC name for this one, right? So you know how to do the how to do write this IUPAC nomenclature. The first rule, you know, the first rule you have to look for the kya? Longest carbon chain, longest carbon chain, including the kya? Functional groups, if possible, including the kya? Functional groups, including the functional groups. Then you have the kya? Least locant rule. Majorly these two rules are important. then you have the kya least locant rule will be there. So 1 degree prefix, 2 degree prefix, word root and the kya, then you will have the kya suffix will be there. Then you have to follow the kya alphabetical order, alphabetical order, and some rules are basically some different rules are there for to write for a specific compound. I will tell you that this one later. For example, see, you have to write this name, right? Double bond, this one. Got it? So it is the kya ketone one, right? This is basically the compound of the ketone one. So what is the longest chain containing the kya functional group? So first thing you have to look for the kya longest chain containing the functional groups. Let it be like this one, longest chain containing the functional groups. Got it? Then least locant rule. Least locant rule means that you have to give the minimum number to the kya functional group, and then after that you have to write out the kya suffix one. So see here, first one, the longest chain rule containing the functional groups. So I have to start from 1, 2, 3. If I end it here, it will be only the 4 one, right? So better I will proceed kya this like this one. Got it? 1, 2, 3, 4 and 5. See, second position is given to the keto one. It is the least one number is given, right? So this is kya right one. So अब क्या लिखते हैं? This 3 one, right? So first you have to write the prefix one, right? So prefix you have to write the kya substituent. Basically this prefix in this one 2 degree prefix you have to write the kya substituent's name, got it? Here you have to write the kya, for example, cyclo, bi, etc. These things are come under kya 1 degree prefixes there. Got it? So write down here the name will be your kya 3 methyl. Got it? So you will have the kya 3 methyl one. Now 1, 2, 3, 4 and 5 means what? Pent. Word root will be kya pent one, right? So I can write here that pent one. Got it? This is kya pent 2 on. Got it? So this will be kya 3 methyl pentane 2 on will be there. Got it? Similarly, if I ask you to write the name for this compound like this one, got it? What is the IUPAC name? IUPAC name for this one. The IUPAC name for this one will be what? It will be, see here, देखो यहाँ पर क्या आ जाएगा, तो क्या लिखोगे? You have to write like this one. Least number must be given to the kya this one, right? So 1, 2 and the kya 3, 4. Got it? So this will be kya butane 2 all will be there. Got it? Understood? What? See, you don't have any prefix here, right? If there is no prefix, there is no need to write the prefix one. Here you will have only the kya suffix one. Suffix here means the functional group name. Got it? So you will have the kya butane 2 all will be there. Got it? Any problem? एक और एक देखो. Suppose you have this compound. What is the name for this compound? Where to start it? It will be start from the longest chain, right? It does not have any functional group. It means it will end with the ane only. Got it? It will end with the kya ane only. So see here, in this 1 degree suffix, this is basically kya ane, ene, ein, etc. Right? Here kya hota 2 degree suffix means the kya? It ends with a functional group name. For example, al. Got it? And all. These things are basically in the kya 2 degree suffix will be there. So see here, in this case you have the no functional groups, right? You don't have any functional group. So first you have to look for the kya longest chain. So I can write here, from here also I can write 1, 2, 3, 4, 5 and 6. Here also I can write 1, 2, 3, 4, 5 and 6. So whether I'll be going from the left to right or the right to left, I have to go from my side. It will be from this side to kya this side, because this will have the least number, right? This will get the least number. So I can write here like this one, 1 2 3 4 5 and the 6 one. Got it? So first you have to write down the prefix one, right? So prefix means you have to write down the substituents here. So first one will be 3 methyl, 3 methyl. Then you have to write hexane will be there, right? So 3 methyl hexane will be there. Got it? Understood these things? Any problem? यहाँ तक सबको समझ में आ गया? अब आगे देखते हैं. You know how to aldehyde ends with the al one, right? Alcohol ends with all one. Got it? You have the anhydride, you have the that one ester. तो अब देखो यहाँ पर और चीज समझो. For example, some special names are there, right? Some special suffix are used. Some special suffix are used. For example, see here, if it is this one, like compound like this one, right? CHO, right? Got it? If it is a cyclic ring and the functional group is next to the cyclic ring, in this case, normal suffix will not be used. Instead of that, some special suffixes are used one, because this will be not included in the principal chain. So the naming will be like 1, 2, 3, 4 and 5 and 6. So see, the functional group is not included in the counting one. Got it? तो इस केस में इसको हम लोग क्या लिखते हैं, साइक्लोहेक्सेन. यू हैव टू राइट लाइक साइक्लोहेक्सेन. गॉट इट? एंड दिस स्पेशल सफिक्स विल बी कार्बल्डिहाइड. सो द स्पेशल सफिक्स विल बी और कार्बल्डिहाइड विल बी. Got it? This is the special suffix are used if this one is not included in your principal chain. If that had been included in the principal chain, the suffix will be al, like propanol, butanol. Got it? But in these cases will be just like carbaldehyde. Or example, dekho, see here, if you have this one, again this will be the carboxylic acid. You know that carboxylic, how it end with the oic acid, right? Carboxylic acid and with the oic acid. That is a normal suffix we used to write. But in this case, since this one will not be included in the principal chain, so I have to write this one as the cyclohexane, cyclohexane, and here you have to write the carboxylic, that is cyclohexane and the carboxylic acid. Got it? So special suffix are used for some compounds. Got it? So if it is a 1 carbon, meth 1. If it is a 2 carbon, then kya? Ith 1. If a 3 carbon, prop, 4 carbon, but, 5 carbon, pent, 6 carbon, hex, 7 carbon, hep, 8 carbon, oct, 9 carbon, non, and last one is the kya? Dec 1. That is sufficient. Got it? So you have this one, suffix and the prefix is written in your kya? This book also. Got it? Understood this one? Okay. Now coming to the next one. They have also given the order of the priority of the functional groups are there. Got it? Order of the priority of the function. ये देखो मैं इसको समझाता हूँ इसको मैं. See here. So what is the order of the priority of the functional groups? So this is important. Why this is important? Suppose two functional groups are there. Suppose you have the aldehyde as well as the alcohol. Then whom to give the priority, right? So that will be determined by the order of the priority of the functional group. Order of the priority of the functional groups will be there. Got it? So see here, the first one will be the first one you can write this one as the this one is important. First one you will have the carboxylic, then you will have the then you will have SO3H, then you will have ester 1, then you will have the COCl, and you will have CONH2, then you will have CN, then you have CHO, C double bond O, then OH, then NH2, then multiple bonds, right? You have C triple bond C, then you will have this one. These are basically the order of the decreasing priority of the functional groups. Now why it is important? इसको देखो यहाँ पर. You see alcohol here, right? Clear है कि नहीं? and aldehyde is here 1. Got it? So what is the suffix for the alcohol? This is all 1. What is the suffix for the aldehyde? It is al 1. All and the al is there. तो अब देखो यहाँ पर, suppose I am giving you the compound like this one, C double bond H1. But this is the aldehydic functional group, isn't it? ये तुम्हारा क्या है? This one is aldehyde, and suppose I have attached the OH here one. Suppose I have attached the OH here. Now the question arises with to give the high priority, right? किसको तुम high priority दोगे? Whether it is the aldehyde or whether it is the क्या alcohol. Obviously, the higher priority will given to the क्या aldehyde one, because this is the compound containing the क्या multiple functional groups is there. Multiple functional. So we'll follow the क्या order of the priority of the functional group. So I have to कैसे लिखेंगे इसको? ऐसे लिखोगे 1, right? Again you have to write क्या 2, here 3, 4, and here will be क्या 5, 1, right? Why I'm starting with the alcohol? Because this has got the high priority. Clear? So this will end with the क्या suffix 1. This will end with the क्या suffix 1. Now see here, this thing, see, this is the main functional group here. However, this is also the functional group, but here in this case it is the क्या main functional group, and this one is basically और क्या side वाला, मतलब next functional group है, and this priority is basically क्या less one. तो अब this will be treated as a क्या substituent for this exam, for in this case one, this will be treated as a क्या substituent one, because here this has got the क्या main, this is basically, or you can write this one is your क्या principal functional, or you can write here is a main functional group here. Clear? So this will be treated as a क्या substituent, right? If OH is used as a substituent, then I have to write this one as क्या 5 hydroxy. This will be treated as a 5 hydroxy. Now this will be turned to the क्या prefix one. यदि अभी आप मेन कैरेक्टर में हो एंड समवन आप क्या होगा साइड रोल हो गए, तो किसका प्रायोरिटी ज्यादा हो जाएगा? जो मेन कैरेक्टर, and you will be treated as a क्या side role. Got it? Similarly, this will be treated as a क्या substance. So I have to write 5 hydroxy. Then the word root. What is the word root here? Will be pent, right? This will be pent, and you have to write the क्या 1 to 5 hydroxy pent 1 pentane 1. Got it? This will be क्या pentane 1. Got it? Understood this things? Any problem? No, right? अब लिखिए, so this is example if the compound is containing more than one functional groups is there. Clear है? अब देखिए the next one, देखो the next one, see here, the next one, see isomerism I am talking about. The क्या isomerism. What do you mean by the क्या isomerism one? What do you mean by the isomerism? What is iso? Having the same isomerism means isomers are the compound having the same molecular formula but different physical or chemical properties or both. Got it? So see here, you know that isomers means isomers means same molecular formula, having the same molecular formula but different physical but different 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 physical different physical or chemical properties, different physical or chemical properties, or both, or क्या both are the examples of the क्या isomers. For example, देखो उसको, you see this one, right? This is the क्या, what is the molecular formula for this one? It is a hydrocarbon, right? So the molecular formula for this one is C4H10. Got it? This will be the C4H10 will be. Similarly, if I have to write this compound like this one, again the molecular formula is not changing. Again the molecular formula is same, right? But still the properties are basically क्या different one. So they are basically the क्या isomers are there. Got it? Similarly, और एक देखो यहाँ पर, suppose you have this one. This is the क्या? This is basically और क्या trans 2 butane, right? This one is basically क्या trans. This is basically the trans 2 butane. Now if I am writing like this one, this is basically or kya, cis two butene. This is cis two butene. Again, having this, they have the kya, same molecular formula, but still the properties are basically kya, different one. So they are basically kya, isomers are there. What is the molecular formula here? The molecular formula is here is C4H8. Here the molecular formula is also kya, C4H8 is there. But still basically both are kya, different one, and hence these are basically the trans and these are basically kya, cis one. Got it? Understood these things? Trans and cis are basically the kya, isomers are there. And so isomers, same molecular formula but different physical and the chemical properties are both are known as kya, are known as basically kya, isomers, are known as basically isomers. And this phenomenon is known as kya, isomerism, and this phenomenon is known as isomerism, is known as isomerism. Got it? Understood these things? अब आगे देखो यहाँ पर, see here, this isomerism can be classified like this one. See here, first one you have to write like structural isomerism, structural isomerism. Okay, structural isomerism. Understood? Then you can write this one as the kya, stereoisomerism, the stereoisomerism, stereoisomerism. What is the difference between the structural isomerism and the kya, stereoisomerism? Structural isomerism, you will have the different connectivity of atoms. Different, you have to write down the kya, different connectivity of atoms will be there, right? Different connectivity of atoms. Here you will have the kya, same connectivity of atoms, same connectivity of atoms, same connectivity of atoms. For example, you will have two parts. One is the conformational, one will be the conformational, and second one will be the kya, configurational one. Configurational one. So what is the conformational isomerism and the configurational isomerism? This will be further classified into geometrical isomerism, and second will be your kya, optical isomerism. Geometrical isomerism, then we will have the optical isomerism with that. In the structural isomerism, you will have the chain isomerism, you will have the chain isomerism. Again, you have the kya, ring chain isomerism, position isomerism. Third one is your kya, ring chain isomerism, ring chain isomerism. You will have the metamerism. You will have the tautomerism. You will have kya, tautomerism. Chain isomerism, ring chain isomerism, and last one is your kya, functional group isomerism. Functional group isomerism. So these are the examples we'll be discussing in the structural isomers and the stereoisomers. तो देखो यहाँ पर स्टार्ट करते हैं. फर्स्ट वन इज योर क्या, structural isomers are there, right? So what is the statement I have written here, that you will have the kya, different connectivity of atoms will be there, right? Different connectivity of atoms will be the first one you write, the structural isomerism, structural isomerism. First example you have the kya, chain isomerism, right? You have the kya, chain isomerism. What do you mean by the chain isomerism? See here, suppose you have the compound like this one. Okay, now you have the compound like, yeah, this one. Got it? What is the chain length here, right? What is the chain length? Here, if you look at the chain length will be kya? 1, 2, 3, 4, and you have the kya? 5, 1, right? The chain length will be 1, 2, 3, 4, and the kya? 5, 1. Here, what is the chain length here? It will be 1, 2, 3, and the kya? 4, 1. Got it? So see, the different chain length is there, right? One has the 5, one has the got the kya? 4, 1. So this is the example of the kya? Chain isomerism. Now, why it is fall in the category of structural isomerism? See the connectivity of the atoms, right? See, थर्ड दो कार्बन से जुड़ा हुआ है, राइट, बट सेकंड इज आल्सो कनेक्टेड विद द टू कार्बन, बट सी हियर टू कार द सेकंड इज कनेक्टेड विद द क्या थ्री कार्बन्स, राइट. It means we'll have the क्या different connectivity of atoms, different connectivity of atoms, so it falls under the category of the क्या chain isomerism will be there. Got it. Now the second example is your क्या position isomerism. Second example is your basically और क्या position isomerism. Position isomerism I am talking about, right? What do you mean by the क्या position isomerism? You know, the position isomerism means you will have the क्या different position of the क्या functional group. Chain length will be same here. Here basically क्या different. Here will basically the different chain length is there. Different chain length is there. Here you will have the क्या different position of functional group. Different position of functional group, and you will have the क्या same chain length. You will have the same chain length will be there. For example, see here. Suppose you have this compound 1, 2, 3, 4, and 5. Suppose here OH is here and here the OH look like this one. See here, what is the chain length for first example in the first one? 5, right? Chain length is basically kya? Chain length you see, it is basically 1, 2, 3 and the 4 and the kya? 5 is there. What is the chain in the second one? The chain in the second one is basically is 1, 2, 3, 4 and the kya? 5, isn't it? What is the position? Here the position is basically kya? Third one. What here? What is the position here? 2, 1. So this falls under the category of the kya? Position isomerism. What is the third one? Third one क्या दिखाया था? Third one is basically your what? Third one is a ring chain isomerism, right? What do you mean by the ring chain isomerism? So see here, what is the ring chain isomerism? Ring chain isomerism. See, ring chain isomerism means, for example, you have this cyclobutane, right? Got it? You have the cyclobutane, and this compound could exist like this also. Got it? So one it is a ring form and one there is a kya open chain, right? So this is example of the kya ring chain isomerism. Got it? You will see the both will have the kya molecular formula. The molecular formula here is C4H8. Here the molecular formula is also kya C4H8 is there. So this is example of the ring chain isomerism that is applicable when the degree of unsaturation is greater than equal to 1. How many double bonds are there? 1, right? Here one ring means one double bond. Got it? So when the degree of unsaturation is greater than 1, you can have the ring chain isomerism. What is the last one? For last उसके बाद क्या लिखा है? That is metamerism, right? You will have the क्या metamerism, right? Metamerism. See, this is only applicable when the functional groups are क्या polyvalent one. This is applicable when the functional groups must be polyvalent one. Polyvalent one. What do you mean by the polyvalent? See here. देखो examples. If you look for the ether, you know ether look like this one, right? Isn't it? Ether is ऐसा ही दिखता है ना, ROR is there. So this is basically क्या ether. So you will have two groups, right? So this is basically bivalent one. Polyvalent means can connect with more than one group. Got it? That is known as the क्या polyvalent one. Suppose you have this example like this one, 1, 2, 3 and like this one. ठीक है. Here it is the क्या ethyl and here it is your क्या 1, 2, 3. That is the क्या propyl one. Got it? Here is your ethyl and here is your क्या propyl one. देखो यहाँ पर you will have this one, right? This one is your ethyl and this one is your propyl. 1, 2 carbon here, 1, 2 and 3 carbon are there. Now I can change this compound. I can write this compound like this also, 1, 2, 1, 2, 3 and the 4, 1. Total how many carbons? 3 carbons. Total 5 carbon. Here also how many carbon? 1, 2, 3, 4 and the 5 carbon. So basically the groups has been changed, right? जो attach है वो groups क्या हो चुके हैं? Change हो चुके हैं. So these are the example of the क्या metamers only. You have the different alkyl groups, right? So in this case basically you have the क्या different alkyl groups are there. Different alkyl. So this falls under the category of the क्या metamerism. This falls under the category of the kya metamerism. 1 2 3 4, and here we will have the kya methyl one. Got it? Now the next one, next जैसे कि और एक भी देख सकते हो. Suppose you have this example ester. Let's suppose this is the example of the ester one. Clear है ना? You have CH2, you have the kya CH3 one. Got it? Understood? Someone wrote like this compound as like this. C double bond O. Here you have the CH3 and you have the kya OCH2 and the kya CH3 one. You see, alkyl groups change, right? Here the alkyl groups are basically this one, and here this one. Here this one, and here you have the kya this one. So basically they have changed, right? So these are the examples of the kya metamerism one. Got it? Now what is the next one? Huh? Which one? Tautomerism, right? So see here, tautomerism, fifth one, right? The tautomerism I'm talking about. So what do you basically mean by the term tautomerism? In the tautomerism, you have to look for the enolizable hydrogen. Enolizable, enolizable, enolizable hydrogen. You have to look for the enolizable hydrogen. For example, see, you have the ketone one, right? Suppose you have the ketone one, and this hydrogen is going like this. This hydrogen is basically going to oxygen one. So this hydrogen is going to a oxygen, that is a polyvalent atom, and it will look like this one. OH, and here will be kya like this one. Got it? So this is kya keto, right? This is basically your kya keto functional group. Here what is the functional group? Double bond plus alcohol, that is kya in plus all. So this is kya in all. So this is example of kya keto enol tautomerism. This is example of the kya keto enol kya tautomerism, where usually the hydrogen is moving from one group to the kya another group if it is enolizable. क्लियर है? तो क्या देखना होता है? यू हैव टू लुक फॉर द अल्फा हाइड्रोजन. यू हैव टू लुक फॉर द क्या अल्फा हाइड्रोजन नेक्स्ट टू क्या नेक्स्ट टू C double bond O, C triple bond N. Got it? And etc. For example, next example you see, suppose I have written the example of this one like this. See, got it? Here this hydrogen is basically or kya inelizable one, because if it is goes like this will form the kya aromatic compound, that is the kya phenol one. So I can write like this compound. This is also a kya keto enol tautomerism. So you have to look for the alpha hydrogen or alpha hydrogen या फिर inelizable hydrogen. Next to kya electron withdrawing groups will be there. For example, whether it will show the tautomerism or not. Suppose see, whether it can show the tautomerism. No, because if you see there is no hydrogen next to the kya C double bond O group. So no tautomerism. So in this example, no tautomerism. This example of the kya tauto. What about the next one? Functional group kya isomerism. The functional group isomerism. See here, the sixth one is your basically kya functional group isomerism. Functional group isomerism I'm talking about, right? What is the meaning by the term of functional group isomerism? Compound will have the kya different functional groups having the kya same molecular formula. So see here, suppose this one, this is basically your kya aldehyde, right? This will basically your aldehyde. Now I can write this compound as also like this one, isn't it? So see, this you have the aldehyde and this will have the kya ketone one. So this example of the kya functional group isomerism one. और एक देखो example, suppose you have CH3 O and the CH3. This one is your ether one, right? Here is your kya? Aldehyde. Here is your aldehyde. Here it is your kya? Ketone one. Here is your ether one, and suppose I am writing like this one, CH3 CH2 and you have the OH one. The ether and you have the kya? Alcohol one, right? Got it? Both will have the same molecular formula but have the kya? Different functional groups. So this example of the kya? Functional group kya? Isomerism will be there. Got it? Understood? Now the next topic is your kya? Stereoisomerism. Okay. In the stereoisomerism, you will have the kya? Same connectivity of kya? Atoms, right? So the next one is your kya? Stereoisomerism. Stereoisomerism, right? What do you mean by that? Stereoisomerism. See here, you will have the kya? Same connectivity of kya? Atom. You will have the same. You will have the same connectivity. You will have the same connectivity of atoms, right? You have the kya? Same connectivity of atoms. Got it? Same connectivity of atoms means all the means the groups which are attached always the kya? Same one. It will not change. For example, in the structural isomerism, you see that connectivity of atoms are basically changing one, but in this case that will not change. The first example I have written, first topic one is will be kya? Conformational isomerism. Conformational isomerism. What do you mean by that? Kya? Conformational isomerism. See, conformational isomerism, you know, around single bond can rotate, right? Around single bond can kya? Rotate one. However, if you want to rotate the double bond, it will be like this. It will be like something. Got it? So around double bond, you cannot rotate the bond. However, in the single bond, you can rotate like this one. Got it? So in this case, if it example of the conformational isomerism, so bond rotation is basically possible, right? The bond rotation is basically possible one. And if it is a rotation, it can go back to its original form, है ना? Because this is basically the rotation one. So this is basically क्या? Intra convertible one. It is basically क्या? Intra convertible one. Got it? तो कैसा bond rotation होना चाहिए? Around the क्या? Single bond rotation is possible. But let me go through the example one. Suppose you have the क्या? Butane. Let's suppose you have the butane one, right? You have the क्या? Butane की बात करते हैं. So what is this? Is CH3 CH2 and you have the क्या? CH3 one, isn't it? Got it? Now it can rotate around this bond also, around this. Many possibilities are there. Let's suppose I have taken the bond rotation around this one. Got it? Around क्या? This one. Clear है? तो देखो यहाँ पर क्या आ जाएगा? So see here, this one is a Newman projection I am drawing, right? Newman projection I am drawing. This one is basically or क्या? Front. Let's suppose I have my eye here, right? Clear है क्या नहीं? तो इस कार्बन से अटैच है दिस CH3 and next one is your क्या? This carbon. So this will be my front carbon, right? And this will be your क्या? Rear carbon. So front carbon will be this one. ये बड़ा सा गोल है वो क्या हो जाएगा तुम्हारा front carbon. And this dot one will be denoted by the क्या? Back carbon. So this one is the front carbon, this one is the front, this one is the rear carbon, right? Rear means the back one. Got it? Now this front carbon is attached with the methyl one, right? This front carbon has got two hydrogen attached and one methyl attached. You see, this carbon has been attached with the methyl one and the two hydrogen, right? Now you have CH3, got it? And you will have the hydrogen and the hydrogen. Got it? Again, you have many possibilities that this carbon, rear carbon attached with the क्या? Methyl one, right? And the two hydrogen. इसको भी मैं ऐसे बना सकता हूँ. See here, I can draw like this one. You have the CH3, you have the hydrogen, and you have the क्या? Hydrogen. Got it? Understood? Any problem? Now see here that see around this is the bond, right? This is the front carbon, is the back carbon. This can rotate, right? Bond rotation is क्या? possible one. If CS3 is just behind the CS3, this is known as the eclipsed conformation, right? This is basically your kya? Fully eclipsed one. It is kya? Fully eclipsed one. This is kya? Fully eclipsed one. Got it. So this will be the kya? Most unstable. Two big groups are just behind to each other, means this will be kya? Most unstable one. Got it. So it's the least stable one. So this will basically or kya? Least stable one. Got it. Now since bond rotation is possible, let's rotate that bond by 60 degree. If you rotate the bond by 60 degree, what will happen? See here. It will look like this one. See here. It will look like you have the CS3, you have the hydrogen, and this CS3 will go, yeah, CS3 hydrogen, and you have the kya? Hydrogen. You see the theta is basically kya? 60 degree, right? Got it. Bond has been kya? Rotated. So the bonds are not just behind the kya? Bond. वो थोड़ा हो क्या हो चुका है? Tilt हो चुका है. So this is basically, one is a fully cliff, this is one of the kya? Staggered one. This is basically or kya? Staggered one. Partially staggered. Got it? Understood? Again, you have to rotate the bond by 60 degree. You will get kya? If you rotate the bond by 60 degree, you will be getting kya? This one. You will be getting the compound like CS3, okay, hydrogen, hydrogen. Again, you will have the kya? CS3, you have the CS3 hydrogen, and you have the kya? This is also eclipse, right? Because bonds are just behind the bonds, but CS3 के पीछे hydrogen है, not CS3 one. So it is a eclipse, but it is a kya? Partially eclipsed one. This is basically or kya? Partially eclipsed one. Got it? Again, if I rotate the bond, you will have, the bond will look like, if I rotate this bond, you will like, it will look like this one. See here, it will look like you have the bond, you have the CS3, and you have the hydrogen, hydrogen. The bond will look like this. Kya? CS3, here you have the hydrogen, and here you have the kya? Hydrogen. Got it? Understood? So see here, CSC are basically kya? Anti to each other, right? This is basically kya? Fully staggered one. This is basically kya? Fully staggered one. So which is the most stable one? Obviously this one. So this is the kya? Most stable one. This is basically the kya? Most stable. This one basically the kya? Least stable one. उसके बाद कौन आएगा तुम्हारा? This will be staggered as basically more stable than the kya? Eclipsed one. Clear है सबसे? उसके बाद ये then it will come like this one. So stability order will be kya? First stability order, then second stability order, you will have the kya? Third stability order, and the last will have the kya? This one will have the kya? Least stability order. So 1 greater than 2 greater than 3 greater than kya? So this is the kya? Stability order will be there. Got it? Because of the repulsion parameter. So in the conformation, the bonds basically can क्या? Rotate one. Got it? Understood यहाँ पर? अब हम लोग next topic की बात करते हैं configurational isomerism, right? The next one is your क्या? Configurational isomerism. Configurational isomerism I'm talking about, right? What do you mean by that? क्या? Configurational isomerism. Configurational isomerism का मतलब तुम्हारा क्या आ जाएगा? See here, दो पार्ट था उसमें, क्या था? फर्स्ट वन इज योर क्या? ज्योमेट्रिकल क्या? आइसोमरिज्म. यू विल हैव द क्या? ज्योमेट्रिकल isomerism is there, right? What do you mean by the geometrical isomerism? In geometrical isomerism, you will have the क्या? Restricted rotation is there, right? Restricted rotation. Restricted rotation means that is not intraconvertible, non interconvertible, non-interconvertible. For example, you see that this one, right? This example, you see this hydrogen and you have the hydrogen one. This is basically your kya? Trans one. And if you switch this one, right, you will get the kya? Like this compound. You will have this, and you will have क्या, this H, and you will have hydrogen. This is the CS3. You have the CS3 and you will have this hydrogen. Got it? CS3 and the kya? CS3. See, around double bond there is a kya restricted rotation. You see that it cannot ये ऐसा ऐसा हो जाएगा, right? So there is no rotation around the kya double bond. Now if you interchange this H with the CS3, see this CS3 and CS3 are 180 degree, right? Wherever in this case this CS3 and CS3 are not at 180 degree, means angles has been kya changed one, right? If the angles has been changed, what does this mean? You will have the different geometry. That's why they are basically kya geometrical isomers. So these are basically kya geometrical isomers. Got it? Next example, you see, suppose you have this one H CS3, you have the kya CS3 and the kya CS3. Got it? Understood? Now if I interchange with this one, if I interchange, you will be getting the kya CS3 CS3 H and the kya CS3. Do you think there is any change in the geometry? No, right? Geometry remains the same. CS3 CS3 ऐसा ही है, ऐसा ही है, ऐसा ही है, ऐसा ही है. Clear? It means that this compound will not show the kya geometrical isomerism. If these two groups are same, then no geometrical isomerism is possible. Got it? Understood? Now the second one is your, this is around double bond. So in double bond you have to look whether these two are same or not. If these two are same, then that will not show the kya geometrical isomerism one. Got it? Now the next one, see here, that geometrical isomerism in kya cycloalkanes. So see here, although it containing the double single bond, but it will not kya rotate one, because this is a locked structure. Ring is basically or kya locked structure. Now this can have this one, right? CS3 and you have the kya CS3 and CS3. This can show the cis as well as the kya transform. This is basically or kya cis form, and we can have the kya transform as well, right? So you will have the kya transform as well. So basically this can show the kya, this can show the geometrical isomerism in cycloalkanes. Similarly, you have this example. Suppose you see the double bond, right? The cyclobutane is there. तो देखो यहाँ पर suppose hydrogen and CS3, hydrogen and the CS3, right? This is basically your cis one, right? Again, I can draw the structure like this also. You have CS3 above and you have the hydrogen and the CS3 look like this one. So see here, what happened here is that this CS3, this CS3, this CS3, and you have the this CS3, right? Got it? So see, this is basically cis one, this will have the trans one. You see, this CS3 are in the same direction, whereas this CS3 one is downwards and one other is upwards one. So both will have the different geometry is there. So hence they are falls in the category of the geometrical isomerism in the cycloalkanes will be there. Got these things? Any problem? अब देखो ऑप्टिकल आइसोमरिज्म की बात करते हैं. व्हाट डू मीन बाय द ऑप्टिकल आइसोमरिज्म? सी हियर, if you look at the optical isomerism, what do you mean by the optical isomerism? So optical isomers means compounds which can rotate the plane polarized light. Compounds which can rotate compounds which can rotate plane polarized light, which can rotate plane polarized light. These are known as like a optical isomerism. Means suppose you have the instrument is there, right? अब उसमें तुमने क्या fill कर दिया? You have that compound, and if you passing the polarized light, whether it will, if you have any deflection in the angle, it means that it will basically or क्या optically active compound. If there is no deflection, it means that there is this compound is क्या optically inactive. But it is impossible to check always the optical activity because you don't have the instrument, right? If you have to see the optical activity, क्वेश्चंस के थ्रू तुम्हें क्या चेक करना पड़ेगा? कुछ ट्रिक्स जानना पड़ेगा so that you can know whether this compound is optically active or the क्या optically inactive one. So in order to know that if it is lack, if compound does not, if compound does not have plane of symmetry, if does not, compound does not have plane of symmetry, okay, and center of symmetry, you have the क्या center of symmetry, then this will compound will be क्या optically active one, then compound will be क्या optically active one, optically active one. You know about the plane of symmetry, right? Plane of symmetry जैसे कि ऐसे मैं आपसे कट करूंगा, right? So my body will be divided into this part and this part, equal half part. Externally थी मैं बात करूँ तो clear है. So we'll have two parts like this one and this one. So we'll have the क्या plane of symmetry will be there. For example, see here, जैसे कि यही देख लो, you have this one mouse, right? Isn't it? If I cut it like this one, you will have two equal halves. So this will have the क्या plane of symmetry will be there. Got it? See, suppose you have this table is there, right? Suppose you have this table, right? इसको तुम ऐसे cut करोगे, so it will be in क्या two equal halves, right? Again you have to cut like this, again it will have the क्या two equal halves. This is known as the क्या plane of symmetry. This is basically known as the क्या plane of symmetry. Now about the center of symmetry, see here. So plane of symmetry is clear, right? So plane which bisects the compound into two equal halves. Got it? A line which bisects into क्या two equal halves, that is known as the क्या plane of symmetry. Got it? Now the center of symmetry, you see, suppose ये देखो, suppose this is the point one, the compound उधर भी गया और उसका opposite में गया, you will getting the same thing. This will have the क्या center of symmetry. For example, if you look at the circle one, right? So circle you will get here, again opposite to that you will get the same thing. If you are getting here opposite to that you will get the क्या same thing. If you are going here, then again you will getting the क्या same thing. Suppose you are getting here, then again you will getting this one. So this will have the क्या center of symmetry. Got it? Does circle have the plane of symmetry? Obviously this will have the क्या plane of symmetry also. Got it? ये समझ में आ गया, क्लियर है. अब देखिए हम लोग नेक्स्ट टॉपिक हम लोग बात करते हैं, दैट वन इज योर क्या कायरलिटी की बात करते हैं, राइट? विच कंपाउंड्स आर कायरलिटी, कायरल कार्बन की बात करते हैं. व्हाट डू मीन बाय क्या कायरल कार्बन, राइट? कायरल कार्बन इज chiral carbon means if carbon is sp3 hybridized, then all the groups must be क्या different one. Then it will have the क्या chiral center. Got it? Of carbon, it can be carbon, it may not be carbon. I'm talking about just the carbon. First thing you have the क्या sp3 and all groups must be क्या different. Then it will have the chiral carbon. For example, see here, if I'm telling this example, does this compound have the chiral carbon? Does this compound have the chiral carbon? बताना तो है क्या? Does this compound have the chiral carbon? Tell me. है? See, if you look at this compound, you will see that this is hydrogen, right? Hydrogen, OH. This is different. This is क्या? Different. So it will have the क्या chiral carbon denoted by asterisk mark. This asterisk mark will denote that it has the क्या chiral center की बात कर रहे हैं. Clear है कि? What do you think? Our hand is off. This one is has got the plane of symmetry or center of symmetry. This one. क्या क्या इसके पास plane of symmetry है? No. Center of symmetry? No center of symmetry. It means that this is basically क्या optically active one. If it is a compound, suppose a compound होता, then this will be your optically active compound. That's why you have to buy different gloves. Gloves are different for the right hand as well as the क्या left hand. If this one has got the plane of symmetry, then you can buy a क्या single gloves, and that single gloves can be right hand भी पहन सकते हो and also in the क्या left hand. Similarly for the you are using you have the left socks as well as the क्या right socks होता है. You cannot use the left socks on the right one and the left one. Clear है? Why is it so? If you look at the, तो अपना नीचे को देखो तो लगेगा it does not have ना क्या any plane of symmetry. Just like this one does not have any क्या plane of symmetry. If जैसे इसका plane of symmetry होता, then you will can wear that one. Got it? So something, see, it seems to like same one, right? But these two are not same. These are basically क्या different one. Can you superimpose over this one? You cannot superimpose. इसको superimpose नहीं बोलते. So basically this one is basically क्या non superimposable क्या mirror images. So enantiomers, I'm talking about the enantiomers, right? Enantiomers, what do you mean by the enantiomers? Enantiomers are basically non superimposable क्या mirror, non superimposable mirror images, non superimposable mirror images, just like this one and the kya this one. This is basically the mirror image, isn't it? This is the mirror image of this one, है कि नहीं? यदि ऐसे mirror है तो तुम्हारे यहाँ suppose mirror है तो you will have this one, but again this is basically क्या non superimposable. Got it? Does this have, this is ये superimposable होगा इसका mirror images? Obviously this will have this, इसलिए इसको तुम उसका कवर लेने जाओगे, राइट? यू कैन बाय वन कवर. ऐसा कभी नहीं आता है कि इसका लेफ्ट कवर राइट कवर. हैव यू सीन? नो, बिकॉज इट हैज गॉट द क्या प्लेन ऑफ सिमेट्री इज देयर. क्लियर है? अब देखिए तो नॉन सुपरइम्पोजिबल मिरर images are there. For example, suppose you have this compound H, you have the क्या CS3, you have the क्या, suppose you have the OH and H, and here you have the suppose C double bond H1. Obviously this one is the chiral one, right? This one is basically क्या optically active one. तो इसी का mirror images कैसा बनेगा? So mirror images will look like this one. You will have the OH, you have the क्या H, you have the क्या CS3, and you will have the क्या C, है ना? Basically क्या आ जाएगा तुम्हारा H, and you will have the this one. So basically these are क्या non superimposable mirror images. These are known as basically क्या enantiomers are there. Got it? These are basically क्या enantiomers. Got it? Now coming to the क्या racemic mixture, right? What do you mean by the क्या racemic mixture? What do you mean by the क्या racemic mixture की बात करते हैं. क्लियर है? तो देखो रेसमिक मिक्सचर का तुम्हारा मतलब क्या होता है. सो रेसमिक मिक्सचर बेसिकली मींस दैट if you have the equal concentration for this one and equal concentration for this one, you know the nomenclature of the R and the S one, you know absolute configuration, how to find the absolute configuration, R nomenclature, S nomenclature, you know. किसी को नहीं पता, देखो मैं बता दे रहा हूँ. So how, what is the rule for the R nomenclature? See, you have to look for the atomic number first, right? So O has got the high atomic number, so it is giving the first priority, right? From this carbon I'm looking, either carbon, either be carbon. Next you have the oxygen, so you will have the second priority, third priority, and you have the kya fourth priority. Got it? So 1, 2 and the kya 3, it look like the clockwise, right? है ना? तो clockwise को हम लोग क्या बोलते हैं? R बोल देते हैं. Clear है? Understood? If it is anti-clockwise, this will be और क्या S1. For example, see here, यहाँ पर क्या है 1 है, 2 है, 3 है, 4 है, right? So 1, 2, 3. This will basically look like the anti-clockwise. But the problem here is that here I have to write the R1, right? But the fourth priority group कहाँ पर है? But the fourth priority group is basically at the क्या horizontal position, right? Then you have to reverse the configuration. Since we are obtaining क्या R, so I have to write क्या S. Here I am obtaining क्या S, but the fourth priority कहाँ पर है तुम्हारा horizontal position, so I have to write this क्या R. Got it? This is the absolute configuration. S and the R is there. Racemic mixture means suppose you have this compound and the equal ratio. Suppose equal ratio of enantiomers, are basically known as the क्या equal ratio of enantiomers are basically known as the क्या racemic mixture. It means यदि ये 1 mole है तो ये भी कितना होना चाहिए 1 mole. That is termed as the क्या racemic mixture. Got it? So this example of the क्या racemic mixture will be there. क्लियर है? अब देखो वन थिंग इज मेसोमर्स नहीं लिखा हुआ, मेसोमर्स देखो व्हाट डू मीन बाय द क्या मेसोमर्स। सो यू हैव द मेसोमर्स सी हियर, mesomers and you have the क्या diastereomers भी एक बच जाएगा। mesomers see here, suppose you have to at least two chiral centers must present, at least two chiral centers must present, and you have the plane of symmetry or the center of symmetry. For example, see here, if you look at this compound, right, OH CS3 and the CS3, and you have the hydrogen and the hydrogen, right? So see here, क्या आ जाएगा, you have the plane of symmetry, right? Although containing the क्या two chiral, at least two chiral center is present. So this is basically और क्या meso compound. Got it? So meso compound overall क्या होता है तुम्हारा? Optically inactive. Optically inactive compound. It is basically your optically inactive compound is there. This is known as the क्या mesomers. What do you mean by the diastereomers? See, diastereomers. See here, these are basically non-mirror images to each other, non-superimposable, non-mirror images, right? Basically, they are not mirror images at all each other. Non-mirror images, got it? Non-mirror images. For example, देखो यहाँ पर example C. Suppose I am writing this example OH, okay? Again, you have this compound as the OH, you have CS3 and you have the CS3 and you have the hydrogen and the hydrogen. Clear? अब देखो ये बेसिकली क्या है, सपोज आई रिटन द कंपाउंड इज OH OH H and the CS3 and the क्या CS3, isn't it? So see here, if you look at this compound, you will see that both are not mirror images, right? They are not mirror images at all. So these are basically क्या diastereomers. In enantiomers क्या non superimposable mirror images, right? And these are क्या non mirror images. These are basically क्या non mirror images. Also, all geometrical isomerism are basically क्या diastereomers. All geometrical isomerism are basically dia. For example, if you have this one, and cis and the trans are basically come under the category of क्या diastereomers also. So this example and this example are the diastereomers में आ जाएगा. Clear? Any problem? Now how to find out the number of stereoisomers, right? How to find out the क्या number of stereoisomers. So देखो यहाँ पर to find number of stereoisomerism, stereoisomers की बात करते हैं. Clear है? तो देखो यहाँ पर suppose I have given the compound like this one, right? This will have the OH and you have the क्या CS3 दे रखा हूँ. Then you have to look for the stereogenic center. You have to look for the क्या stereogenic center की बात करते हैं. How to look for the stereogenic center? So see here that this is the carbon, this is the chiral carbon, isn't it? You will have the chiral carbon. Here also it can be cis as well as the क्या trans. So how many possibilities? 2 into 2. So number of stereoisomers will be क्या 2 का power 2. That is how much? 4 stereoisomers. So you have to look for the क्या chiral center as well as the क्या around double bond, whether it is showing the geometrical isomerism or not, because you know around geometrical isomerism it can be क्या cis as well as the क्या trans one. It can show the cis as well as the trans. So two possibilities multiplied by two possibilities give you क्या 4 possibilities. This is how we find out the क्या number of stereoisomers. एक और एक क्वेश्चन पूछता हूँ. See how many stereoisomers for this compound is possible? How much? Only 2 is possible. So you will have the क्या 2 is possible, that is 2 का power 1 is equals to how much? 2 will be. This is how we find out the क्या number of stereoisomers. Got it? Now coming to the bond fusion, right? Now coming to the क्या bond fusion, right? So see here, bond fusion one, right? Bond fusion. What do you mean by the fusion means क्या breaking one, right? Fission means something breaking one. So one will be और क्या homolysis, one will be और क्या homolysis, and second will be your क्या heterolysis will be there. Second will be your क्या heterolysis will be there. Got it. So what do you mean by the homolysis? Suppose you have A and the A and B is there, right? A and the B is there. Got it. Now, if it is breaking homolytically, means equal number of electrons is going to A as well as the क्या B1. So this will be under the category of क्या A radical plus the B radical. These are the क्या radicals. So this is example of homolysis. Now it can break heterolytically also. Suppose you have this compound A and the क्या B1, right? And the electronegativity of B is greater than electronegativity of क्या A1. So it will look like क्या? So it will look like this one. Means both electrons is going to the क्या B1, right? So it will be A plus plus क्या B minus. So this is the क्या heterolysis one. Here is the unequal distribution of the क्या electrons. Here will be क्या equal distribution of क्या electrons. So in homolysis equal distribution of electrons, in heterolysis unequal distribution of क्या electrons की बात कर रहे हैं. Clear है? Now coming to the next topic is your क्या attacking reagents, right? Now next topic is basically your क्या attacking reagents. See here, what do you mean by the क्या attacking reagents? What do you mean by the attacking reagents? One is your electrophile, another will be your क्या nucleophile. One is your क्या electrophile, and second one will be your क्या nucleophile will be there. Second one will be your क्या nucleophile. Got it? Understood. So what do you mean by the electrophile and the क्या nucleophile? See here, electrophile, electro means electron, phile means क्या loving one, right? So it is basically your क्या electron loving species. This is basically क्या electron loving species. Which species will love electron? Which have the क्या scarcity of क्या electrons? The species which have the scarcity of electrons will attract the electron density towards it, isn't it? For example, you have the H plus, right? So H plus has the scarcity of electrons, so it will attract the electron towards. That is why it is क्या electron loving species. Similarly, you have the क्या CS3 plus, that is the क्या this is also a क्या electrophile will be there. Now nuclear loving will be क्या nucleus loving species. This will basically or क्या nucleus loving species. Got it? Understood? Nucleus loving species means it will attract the क्या electron density towards it. Nucleus means क्या proton, right? So proton loving species means attracting electron density towards it. It means that it will have high electron density. इसके पास electron density क्या होगा बहुत ही ज़्यादा होगा. For example, you have OH minus, isn't it? So it will have more electron density and hence it will attract the electron density towards it. So this will be a nucleus loving species. For example, CS3 minus all fall under the category of the क्या nucleophile will be there. Now this is clear, right? Any problem? अब देखो हम लोग बात करते हैं next one is your basically electron displacement defect, right? Electron displacement defect की बात करते हैं, right? electron displacement effect की बात करते हैं. electron displacement effects, right? electron displacement effects. Got it? So first one, talking about the permanent effect, you have the क्या inductive effect. First one is your inductive effect. Inductive effect का मतलब क्या होता है समझो यहाँ पे. What do you mean by the inductive effect? It is arising due to क्या polarity in the bond. It means it is arising due to the क्या electronegativity difference. How is it arising? See, it is arising due to electronegativity difference, due to electronegativity difference. Got it? So see here, for example, suppose you have the bond C and you have the क्या let's suppose X is there. ये तुम्हारा कुछ है हाइड्रोजन 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 हाइड्रोजन. Clear? Now you know that X is more polar, right? Since X is more polar, so what it will do, what it will do basically that ये क्या करेगा, see here, it will attract the electron density towards it, right, isn't it? See, X is more electronegative. More electronegative means it will pull the electron clouds towards it. It will pull the electron clouds towards it. So it will make the carbon to be kya? Positive one, right? So it seems that electron density is flowing from this side to this side, right? Got it? So X is taking the electron and this group is basically kya? Giving the electron, right? Why is it arising? Why is it arising? You know, because arising due to what? Because of the electronegativity differences, because of the electronegativity. So since the electron which are giving, this is known as the kya? Plus I group, and this X is basically kya? Taking the electron density towards this is known as the kya? Minus I group. So I can write here that this plus I effect and the minus I effect, plus I effect and the kya? Minus I effect, it means that kya? Electron pushing one, right? Clear? Electron density को क्या कर रहा है? Push कर रहा है. Whereas this minus I effect is basically क्या? Electron withdrawing. Got it? Electron withdrawing, or you can say electron attracting one. Clear है क्या? For example, see here. Suppose you have the benzene ring, right? और इसे क्या अटैच कर दिए? C double bond H अटैच कर दिए. Clear? Obviously, this group will basically क्या? Attract the electron density towards it, right? So it will show the क्या? Minus I effect, and this will show the क्या? Plus I effect. So the arrow will be क्या? Like this one. Clear? It is going from the क्या? Plus I to the क्या? Minus I will be there. Now, which groups are showing the plus I effect and which groups are showing the क्या? Minus I effect. Generally, alkyl groups will show the क्या? Alkyl groups है कि नहीं? Alkyl groups, negatively charged groups will show the क्या? Plus I effect. Whereas in this case, minus I effect will be shown the क्या? Positively charged groups है कि नहीं? Key atoms having positively charged groups and the electronegative elements, electronegative elements will show the क्या? Minus I effect. Clear? Electronegative elements will show the, जैसे कि एक और एक क्वेश्चन देखो, फॉर एग्जाम्पल देखो यहाँ पर, सपोज यू हैव साइक्लोहेक्सेन, यू हैव द फ्लोरीन वन, राइट? Fluorine is the electronegative element, isn't it? So it will take the electron density towards it. So it will take the electron density kya? Towards it. So it will have the kya? Minus I effect, and this will have the kya? Plus I effect. Minus I, and this will have the kya? Plus I effect will be there. Got it? This is how we know plus I and the kya? Minus I will be there. Got it? अब देखो the next one. The next one is your क्या? Basically hyper conjugation, right? The next one is basically और क्या? हाइपर कॉन्जुगेशन की बात करते हैं. क्लियर है? तो देखो यहाँ पर हाइपर कॉन्जुगेशन, सी हियर, हाइपर कॉन्जुगेशन, हाइपर कॉन्जुगेशन. सी हाउ टू सी द हाइपर कॉन्जुगेशन, ऑल्सो नोन एज द क्या? बेकर नाथन इफेक्ट. कहाँ देखना होता है ये देखो. सपोज यू टू लुक फॉर द अल्फा हाइड्रोजन नेक्स्ट टू क्या? डबल बॉन्ड, नेक्स्ट टू रेडिकल, next to carbocation. Okay, you have to look for the alpha hydrogen attached to sp3 कार्बन. क्लियर है? इन तीनों में आपको क्या रखना होगा ध्यान? यू हैव टू लुक फॉर द हाइपर कंजुगेशन. फॉर एग्जांपल सी हियर, इफ आई एम आस्किंग यू दिस कंपाउंड CH3H, you have the H and you have the क्या? CS3 one. So as I told you that you have to look for the alpha hydrogen attached to sp3 carbon, attached to alpha sp3 carbon around double bond, right? This is double bond, this will be your alpha position. Around double bond, this will be your kya? Alpha position. And the hydrogen attached with the kya? sp3 carbon. So it will have the 3 hydrogen and you will have the kya? Total how many hyperconjugation? 6. Got it? This is about the kya? Double bond. Now coming to the carbocations here, suppose you have the carbocation look like this. Carbocation CH3. You have the CH3 and you have the kya? CS3 is there. isn't it? So this is carbocation. This is basically your kya? This is basically your kya? Alpha. This is the alpha, and this one is basically your kya? Alpha position. Got it? Now the hydrogen attached with the alpha sp3 carbon. So total how many hydrogens are there? 3 plus 3 plus 3, that is kya? 9 alpha hydrogens are there. Now radical, for the same case of the kya? A radical will be there, right? So see here, radical, see here, CH3, you have the kya? CH3. How many alpha hydrogen? See here, कितने होंगे alpha hydrogen बताओ? Total will be how much? How many alpha hydrogen will be there? 6 alpha hydrogen, right? So this alpha hydrogen will be how much? This alpha hydrogen will be 3 plus 3, that will be how much? 6 alpha hydrogens are there. 9 alpha, 6 alpha, here we will have the 6 alpha. This is also known as the Baker-Nathan effect. This is also known as the Baker-Nathan effect. Got it? Now the last one is basically your resonance. The most important one is basically your resonance. What do you mean by the resonance? So see, resonance means movement of the electron density. It is basically your movement of the electron density will be there. It is basically your electron density one. Got it? So see here, what does this mean? The electron density one, देखो यहाँ पर, suppose you have the benzene ring, right? You have the benzene ring. Okay, now you know that this pi electrons can move, so it will look, it can go here, it can go here, it can go here, so this will be like this one, isn't it? So these are basically the canonical structures. So the real structure will be like real structure will be having the characteristics of this structure as well as the this structure. So this compound will look like this one. इसलिए तुम लोग कैसा बनाते हो, बेंजीन के ऊपर ऐसा बनाते हो ना, गोल वन, राइट? This is basically the resonance one. Got it? So this is the basically, these are the canonical structure. These are basically the canonical structures. Canonical structure, and this is basically your resonance hybrid. This is basically your resonance hybrid will be there. Got it? This is basically your resonance hybrid. और example देखो, suppose you have the CH3 C double bond O and the negative one. Got it? तो क्या होगा? This will go like this one. So the resonating structure will look like CH3 CO minus, and you have the double bond. These are the resonating structure. So the resonance hybrid will look like resonance hybrid will look like CH3 COO and minus half, you will have the minus. This is the resonance hybrid will be there. These have existence only in the copy and the paper. In the pen, मतलब copy paste का existence. This does not have any real, no real existence, no real existence. Only the real existence will be have the resonance hybrid. So this will have the real existence, real existence. Clear है? ये समझ में आ गया? This is all about the resonance one. Now coming to the acidic strength and the basic strength, right? Acidic strength and the basic strength, right? Acidic strength is basically favored by minus m, minus r, minus h, and the minus I. Got it? Whereas the basic strength is favored by basically favored by plus m, plus r, plus h, and the plus I effect. This is how we check the acidic strength as well as the basic strength will be there. More the plus m effect, more will be the basicity. For example, देखो यहाँ, what do you mean by the mesomeric effect? See here. देखो mesomeric effect, you have two types. Mesomeric effect, see here, you have the plus m effect. देखो यहाँ पर plus m effect. Suppose you have this part, NH2, right? You see, if you're doing the NH2, the electron density will go inside the ring, right? It means that this NH2 is basically, this NH2 group increases the electron density, increases the electron density in the क्या benzene ring, electron density in the क्या benzene ring, electron density in the क्या benzene ring. So basically this is the क्या plus M effect. This will show the क्या plus M effect. So the it will look like क्या, it will look like double bond NH2 plus minus and look like this one. You see the negative charge is coming in the ring one, right? So basically increasing the electron density. So what is the criteria here for the plus M effect? It must, the group which is connected with the benzene, it must have the lone pair. If it has a lone pair, it will show the plus M effect कहाँ पर? At ortho and the para position. So this is basically a ortho para directing group will be there. Now coming to the minus M effect. Now coming to the minus M effect, right? Minus M effect का मतलब समझो. Suppose you have the group like this one. Sub C double bond H is there, right? C double bond H is there. So it will take the electron density away from the ring, right? Making the ring to be क्या? Positively charged. Making the ring to be क्या? Positively charged will be there, right? So see here, it is taking the electron density away from the ring. That is known as the क्या? Minus M effect. That is basically known as the क्या? Minus M effect will be there. Clear है? बाकी अब देखो next one, the reaction intermediates, right? The reaction intermediates. See here, reaction intermediates, reaction intermediates. Intermediate means you have the क्या carbocation. Same thing, carbocation stabilized by क्या? Stabilized by carbocation stabilized by plus M effect plus H and the क्या plus I effect. Second one, you will have the क्या carbon ion, right? Carbon ion will be stabilized by stabilized by minus M minus M minus R minus H, and you have the क्या minus I will be there. Third one, radicals you have to see hyperconjugation stabilized by hyperconjugation stabilized by hyperconjugation stabilized by hyperconjugation and the क्या inductive effect and the inductive effect. Clear? कुछ क्वेश्चंस को मैं समझाता हूँ, ठीक है? Then the purification I'll be discussing tomorrow. One very big chapter. See here, start करते हैं. Question number पे start with previous KCETs, right? Previous KCETs. Question number 10 1. Question number 10 क्या होगा? Question number 10. See here. If you look for the question number 10, you see this will be your क्या OH, and here you will have the क्या like this. Got it? You see क्या सबसे प्रायोरिटी किसको देंगे हम लोग? Obviously ketone, right? So it will be क्या 1 2 3 4 and the क्या 5. So it will be क्या 4 hydroxy, then क्या pentane 2 on, right? Got it? Which option? First one. 2 pentanone या फिर pentane 2 1 will be there. Got it? Acetone and propanol, which kind of isomers? Acetone and the propanol functional group isomers are there. क्लियर है आप लोग को? चलिए और एक देखिए. Now see here, only the IUPAC name is there. Question number previous NEET, right? Previous NEET खोलो, previous NEET है ना? Question number first one, which is linear one. Linear will have the क्या? Which compound is basically linear? Sp hybridization will compound will be क्या? Linear one, right? So see here, if you look for this example, CS3 and you have the क्या C triple bond C and the क्या CS3, right? sp3 carbon means sorry sp carbon, this is basically sp and this is also kya sp means kya linear one. So third option will be the kya correct answer. Now question number 2, which of the following is not electrophilic in nature? Question number 2, which of the following is not electrophilic in nature? Which one? हाँ क्या होना चाहिए? H3O plus Y. See here, why H3O plus is not electrophilic in nature? See here, if we look for the example, OH, H, and you have the H1, right? It is a positive one, right? Although it contains the positive charge, but still it cannot accept the electrons because it does not have any vacant orbital one. Got it? Although it contains the positive charge, it does not have any vacant orbital to accommodate the extra electron seat. It is already 8 electron, octet is complete, right? Octet से ज़्यादा होने के लिए क्या होना चाहिए था? You must have the vacant orbitals. That is not in the case of क्या? This one, right? Got it? चलिए फिर अब देखो question number 6. Which of the following molecules represent the order of hybridization sp2, sp2, sp and the sp from left to right? बताओ क्या आएगा? sp2, sp2, sp and sp. Which option? See here, third option, right? See, CH2, you have CH2, है ना? You have C triple bond CH, right? sp2, double bond. This will be your क्या? Double bond sp2. This is क्या? Triple bond, right? sp and here has क्या? sp1. क्लियर है आप लोग को? ये समझ में आ गया? अब देखो, now question number 12 is not an aromatic compound. Which of the following is not an aromatic compound? Which of the following is not an aromatic compound? बताओ. Which of the following is not an aromatic compound? First one is aromatic compound, 6 pi electrons, isn't it? Second one, third है, चलो मैं बता दे रहा हूँ. And the last one, see here, if I'm looking 12, right? First one, see, first one is the example of the क्या? Aromatic compound, right? Clear? 6 pi electrons are there, right? That is क्या? 4 into 1 plus 2, that is 6. So it is the aromatic one. Now the second one, you see, this the example look like this one, positive, right? This is क्या? 2 pi electrons, right? That is how much? 4 into 0 plus 2, that is equals to क्या? 2 1. Clear है कि नहीं? This is also क्या? Aromatic. This is also aromatic and this is also क्या? Aromatic one, isn't it? Now the third one, you see, third one देखो, this one will look like क्या? This one, है ना? The problem here is that although it contains the 6 pi electrons, but this is क्या? sp3 carbon, right? Means non-planar one. So this will basically क्या? Non-planar compound, non-planar one means एक plane में नहीं है. So it is क्या? Non-aromatic compound. So which option will be the correct one? Third option. Because the last one is also a क्या? Aromatic compound. देखो, this will look like this one. Negative है ना? तो ये resonance में डाला जाता है. So basically it will have the क्या? 6 pi electrons. So last one is also क्या? Aromatic compound. This is also क्या? Aromatic compound is there. Now question number 17 you see, right? Question number क्या? 17 की बात करते हैं. Clear है? Which of the following is the क्या? Most stable क्या? Carbocation, right? You know, question number 17, most stable carbocation among the क्या? Following. How to check for the stability of the carbocation? Stability of carbocation, see here, stability of carbocation क्या क्या देखना पड़ता है देखो. In order to check for the stability of the carbocation, first you have to look for the क्या? Plus M plus R plus H and then क्या? Last one is your क्या? Plus I effect. Got it? तो देखो यहाँ पर पहला क्या है? This one, right? CH3, you have the क्या? CH plus you have the क्या? CH3 and you have the CH3. Obviously there is no resonance. How many alpha hydrogens are there? How many alpha hydrogens? देखो, एक दो and you have the क्या? 3 1, right? So basically 3 alpha hydrogens are there. So basically here क्या? 3 alpha hydrogens. Got it? Now the second one, right? Second one देखो. If you look for the second one, see here, CH3, okay, CH positive, you have the क्या? CH2, you have the CH, you have the CH3, and you have the क्या? C. How many alpha hydrogens are there? How many? You have alpha hydrogens to be 3 and 2, right? Total how much? 5 alpha. You will have the क्या? 5 alpha hydrogen. Now the next example you see, कितने alpha hydrogen है देखते हैं. See here, देखो, example of this one, CH2 plus, how many alpha hydrogen? कितने हैं? देखो तो, you have only how much? Only one alpha hydrogen, right? Isn't it? And the last one you have to see that this example, like this one, positive CH3. How many alpha hydrogen? बताओ, how many alpha hydrogens are there? बोलो. 3, 2, 2 and 2. Roll how much? 7th, which is the most stable one. 7 alpha hydrogen will is the क्या? Most stable one. Got it? ये समझ में आ गया? चलिए फिर बाकी ये चैप्टर को कल कंप्लीट करते हैं ना. Then we'll start with the haloalkanes, the halogens.